Hello friends, welcome back to the online certification course on watershed hydrology. I am Rajendra Singh, professor in the Department of Agriculture and Food Engineering at Indian Institute of Technology, Kharagpur. We are starting module 3 today. This is lecture 1, Streamflow processes. And in this lecture, we will introduce streamflow processes. Then we will talk about the mechanism of streamflow generation and the types of streams. Coming to streamflow, it is the most visible component of hydrological cycle. That means you can, this is one of the process which you can really see with your naked eyes. And streamflow refers to the volume of water passing through a fixed location on a river in a unit of time. So, it could be a river, stream or water course. So, any point if you take on that and if you find out the volume of water passing through that particular location or cross section over a period of time, then that is a stream flow. And it is usually expressed as cubic meters per second or cumecs, which is short cubic meter per second is referred to as cumic. It may also be expressed as the depth of water over the surface. That means, if you with reference to this, if you know the basin area or the catchment area, then you divide the volume by the catchment area. So, whatever we get the in depth units, that is also referred to as stream flow. If you look at the processes involved in stream flow, then obviously it all starts with precipitation. So, precipitation when it occurs, then a part of the precipitation falls directly on the channel or stream or the river. So, that is channel precipitation. But other than that, next is when the water comes, the precipitation water comes in contact with the soil surface, the infiltration starts. And after satisfying the infiltration process, the overland flow occurs. And if this infiltration, a part of it that becomes interflow, and rest, that means interflow means it flows close to the surface of the soil, parallel to the surface, and then remainder due to gravity it percolates down and joins the groundwater. Now, this interflow has two components. One is rapid interflow, other is a delayed interflow. Now, this rapid interflow, a part of it may join or reappear on the soil surface in the form of exfiltration, which is just reverse of infiltration is exfiltration, and then this overland flow and exfiltration combined together, they are surface runoff, and that forms a part of and of course, it is joined by channel precipitation. That is one component of the stream flow. On the other side, we have delayed interflow. So, a part of that joins the percolation and joins the groundwater, but a component of rapid as well as delayed interflow that forms surface runoff. That means another form of, so there is a surface runoff, there is subsurface runoff, and there is a groundwater flow. And this subsurface runoff and groundwater, they join together to form base flow. So, and this overland flow or surface runoff plus base flow combined together, they form the stream flow. So, stream flow has two major components. One is surface flow, the other which comes from the ground, that is base flow, and this is reverse. We can see how these processes occur starting from precipitation in a hydrological cycle. Now, if you talk about the processes one by one, so surface runoff is the portion of precipitation that flows over the ground surface and ultimately reaches streams, rivers, lakes or other water bodies without infiltrating into the soil, which is quite obvious because we know that when precipitation reaches the earth's surface, the first thing is satisfies the infiltration capacity of the soil. We saw yesterday in the previous lecture we studied the infiltration, and we saw the infiltration capacity of the soil has to be satisfied first, and then only overland flow takes place. So, that is surface runoff, and this includes overland flow and also rapid interflow just now we discussed. Then there is a base flow, that is the sustained relatively constant flow of water or stream that comes from slow and steady release of surface or groundwater into the stream. That's base flow. So, as in the previous slide we saw that there are two major components, one the surface runoff and the other is base flow, which form stream flow. So, of course, as we have seen by definition, surface runoff is a quick flow overland flow and it follows a precipitation event. But on the other side, we have a sustained relatively constant flow of contribution to river or streams, which comes from slow and steady release of subsurface or groundwater flow. Base flow typically remains relatively constant over time, providing a consistent minimum flow in the river or stream. So, base flow is primarily the region of perennial rivers having flow throughout the year, because the surface runoff or overland flow, that is contributed only when precipitation occurs, but during the dry season or non-monsoon season, it is the base flow that sustains the flow in a perennial river in the form of base flow. Then of course, we also talked about interflow, which is the lateral movement of water within the soil profile, often between soil layers or horizons. The water movement typically occurs parallel to the ground surface, but below the surface. So, here you can see that here its overland flow is occurring on the surface, and just below the overland or the ground surface, we have a flow taking place, which is interflow. And it could be of two types, rapid interflow and delayed interflow. Now, rapid interflow is the swift movement of water through the soil profile during or immediately after an intense precipitation event. So, obviously, the entire interflow process starts only after a precipitation event when infiltration has taken place. Infiltrated water starts moving and it moves swiftly, then it is called rapid interflow, and a significant portion of this rapid interflow may reappear on the surface and join the overland flow. So, this may if the soil profile is so, then this water may come on the surface and join the overland flow, and that is the rapid interflow. Then there is a delayed interflow, that is the gradual movement of water through the soil layers following a precipitation event. It follows the rapid interflow and continue for an extended period. So, rapid interflow is pretty quick. Quickly the water surface, the interflow starts moving parallel to the surface, and then if the soil profile permits, it reappears on the ground surface, wherein the delayed interflow moves slowly and joins the groundwater, and it continues for a longer period of time, which is very slow release of water is there in the case of delayed interflow. Then coming to variation of processes in a precipitation event, then of course, we know that the precipitation contributes to various storages and flow processes, and this figure shows the variation of various processes relative to precipitation rate. So, here on this scale you have 0 to 100, that is the rate related to precipitation rate, and this is the time since the precipitation began, that is on the x-axis. So, if you look at the figure, on the top here and at the bottom here, there are two straight lines portions, and one of them is channel precipitation, the other represents the interception and evapotranspiration. So, a portion of precipitation falls directly on streams, that is refers to a channel precipitation. So, whatever precipitation occurs directly on the surface of the stream or river or water course, that is channel precipitation, wherein precipitation also satisfies the interception and evapotranspiration requirements. So, that is why a percent of precipitation is being considered in the form of interception and evapotranspiration. Of course, beyond that, the first requirement, the first abstraction which precipitation satisfies is infiltration. So, it is a continuous, but a large portion of water goes in the form of surface storage first and then soil moisture storage. So, here you can see surface storage and soil moisture storage, and in both cases the storage has two components, retention and detention, which will define in next slides. So, what happens that a large portion of the precipitation contributes to surface storage. Just now we saw that after channel precipitation, after interception and evapotranspiration and after infiltration, the next thing which occurs is surface storage. If there is water infiltrates into soil, there is also soil moisture storage. So, there is a surface storage here and soil moisture storage here. So, you can see the components here, the percentage of total rainfall. Now, any storage could be of two types. One is retention, other is detention. These terms are pretty common, so it is important to know the difference between these two. Retention is the storage held for a long time, a long period of time and depleted by evaporation, and it mostly occurs on surface, on overland flow. As we discussed that when overland flow starts, if there are potholes on the ground, then obviously a part of the overland flow will be stuck there, and that is retained there and gets evaporated or infiltrated. That is, it depletes either by evaporation or infiltration, and it does not become a part of the overland flows. The next one is detention, which is a short term storage depleted by flow away from the storage location, and that is basically this is detention. Basically, as we know that for any flow to take place, we require head. So, the water which is required to build the head for flow to start taking place, that storage is referred to as detention. So, basically it is a short term storage which depleted away by flow away from the storage location. So, of course, when head will be built and if inflow stops, then obviously it will deplete slowly in the form of overland flow. As retention storages begin filling, flow away from them occurs in the following form. So, when the detention, the sufficient head has been generated, then obviously there will be overland flow across the land surface. As you can see here, there are three different flow processes: overland flow, unsaturated flow and groundwater flow. So, overland flow across the land surface, unsaturated flow through the unsaturated soil near the land surface, that is very close to the ground surface, and groundwater flow through saturated aquifers deeper down. And all these three contribute to channel flow. So, ultimately all the flow processes contribute to channel flow. Thus, channel flow is the main form of water flow and all other processes contribute to it, just how we saw. And determining flow rates in stream channels is central task of surface water hydrology. So, basically what this means is that how precipitation occurring on a basin, on a watershed gets converted into channel flow, that is what we study in hydrology. That is the central focus of study. In other terms, we can also say that the central task of surface water hydrology is studying the rainfall runoff transformation process. That means how rainfall gets converted or transformed into runoff, which of course we measure in the form of channel flow, and that is what is the central task of hydrology. Now, stream flow generation, if we look back, then there are three forms we have said: overland flow, groundwater flow and subsurface flow. Now, once precipitation starts, water reaches the ground surface, of course, the first thing will be infiltration, but then water will start moving on the surface. That is number one, and that is referred to as, that's overland flow we already mentioned, but it is a typically called infiltration excess overland flow. That is a part of precipitation which is there in excess of infiltration requirement or infiltration capacity of the soil, that flows in form of overland flow. That is infiltration excess or Hortonian overland flow, because Horton he gave this term. So, that is why it is also referred to as Hortonian overland flow. Then of course, there is a infiltration occurs, and of course, as we have seen that a part of it percolates down, percolates down, joins the water table, and of course, this water table flows and again contributes to stream flow as we have seen in the form of base flow, and this second type of flow is groundwater flow. Then of course, we have also seen that when infiltration takes place, then in highly permeable top soil, the flow starts taking place parallel to the ground surface, and this is referred to as subsurface flow. We also saw that similar to interflow, And then of course, the fourth type of flow is saturation excess overland flow, and that happens basically near the foothills of this foothills. As you can see that what happens, that the groundwater really comes to the surface, and or a part of the subsurface flow or interflow reappears on the surface, and so that this surface, the ground surface, gets saturated. And if it is a saturated ground surface, that is here, so whatever precipitation occurs directly on this saturated surface, then obviously that will be converted into overland flow, and that is referred to as saturation excess overland flow. So that means we can I repeat that there are two types of overland flow: infiltration excess or Hortonian overland flow, which occurs when precipitation satisfies the infiltration and water starts flowing on the surface, and the other is saturation excess overland flow, when soil gets saturated from the bottom, and then if the ground surface is saturated, then whatever precipitation occurs directly on this saturated part, that gets converted into overland flow, and that is a saturation excess overland flow. Now, coming to infiltration excess overland flow, it was the Horton in 1993 that described this process, and that is why it is also referred to as Hortonian overland flow. And Horton described this overland flow as neglecting interception by vegetation. Surface runoff is that part of rainfall which is not absorbed by soil by infiltration. So, that is why we said that first requirement is satisfying the infiltration capacity of the soil, and once that is done, then whatever flow takes place, that is overland flow or surface runoff. If the soil has an infiltration capacity F expressed in inches depth absorbed per hour, then when the rain intensity I is less than F, the rain is all absorbed and there is no surface runoff. That means, if I is less than F, where I is the rainfall intensity, F is the infiltration capacity, then obviously if I is less than F, then everything is absorbed in the form of infiltration and there is no overland flow. Thus, it may be said as a first approximation that if I is greater than F, surface runoff will occur at the rate I minus F, and I here is of course after satisfying the initial requirements. So, that is why that is important, that is neglecting interception by vegetation. So, to certain extent we can also say that it is minus initial abstractions, rainfall intensity minus initial abstractions. Now, Horton termed this difference I minus F as rainfall excess, or we have also termed this earlier as effective rainfall. So, either effective rainfall or rainfall excess. We remember we discussed about the phi index. So, it is similar to that, that from precipitation, if you take away all the losses including infiltration, then the remainder of rainfall intensity or rainfall is termed as effective rainfall or rainfall excess. Horton considered surface runoff to take the form of a sheet flow whose depth might be measured in fraction of inch. So, basically this overland flow or surface runoff occurs in the form of a sheet flow, that is a very thin layer of water starts flowing on the ground surface. As flow accumulates going down a slope, its depth increases until discharge into a stream channel occurs. So, obviously, if there is a sufficient slope, then as the overland flow will start taking place, more and more flow will join. So, the thickness of the sheet that started this thin layer, that will grow as the flow moves down, and finally the discharge into the final stream or stream will occur. Along with overland flow, the following also occur: depression storage in the surface hollows that we have discussed, surface detention many times, and depression storage, and surface distension proportional to the depth of overland flow. So, that means we just now we talked, this is nothing but retention, because water is retained in hollows, and this is detention because we said that sufficient depth will be required for building the head for flow to take place from a particular location. So, the soil stores infiltrated water and then slowly releases it as subsurface flow to enter the stream as blaze flow during the rainless period. Hortonian overland flow is applicable for impervious surface in urban areas. That means, if it is paved area, then obviously whatever rainfall occurs on this paved area, that gets translated into overland flow automatically or surface runoff. And natural surfaces with thin soil layers and low infiltration capacity age in semi-arid regions. So, if the infiltration capacity is low, then also excess rainfall will start moving in the form of overland flow. Hortonian overland flow occurs rarely on vegetated surfaces in humid regions because of simple reason that the infiltration capacity is high. Also, because of the littering on the soil surface, a lot of water gets retained on the surface. So, that is why there is a seldom overland flow occurring under such circumstances. Then the other part, we have saturation excess overland flow. Saturation excess overland flow is produced when subsurface flow saturates the soil near the bottom of a slope, and overland flow then occurs as rain falls on the saturated surface. Just now we saw in the picture that if we have this kind of situation where the water table, this is the water table, and if this water table rises, then it might saturate this portion, let us say, and so if this portion gets saturated, so whatever precipitation will occur on this surface, that will get translated into saturation excess overland flow. So, saturation excess overland flow differs from Hortonian overland flow in that in Hortonian overland flow, the soil is saturated from above by infiltration. So, that means precipitation occurs and then infiltration occurs and then it saturates the soil and then flow starts taking place. While in saturation excess overland flow, it is saturated from below by subsurface flow. So, that means subsurface flow or due to groundwater table rise, the surface gets saturated from below and then precipitation, whatever precipitation occurs on this surface, that flows as a overland flow. So, this is the pictorial view of the two, that is first one is infiltration excess overland flow. So, excess water that cannot infiltrate ponds on the soil surface and eventually starts to flow down slope across the soil surface. So, here precipitation is occurring and of course, some water infiltrates and then as a form of thin layer it starts moving on the soil surface. Where in saturation excess overland flow case is shown here that subsurface flow returns to the surface when the capacity of the soil to transmit flow is exceeded. Any rain falling on the saturated zone adds to the overland flow. So, here also in rainfall infiltration is taking place, but because of the soil characteristics there is a flow parallel to the ground surface and then this flow is reappearing and this part of the land surface is getting saturated. So, if any precipitation occurs on this surface, that gets translated into form of a saturation excess overland flow. We can also understand this in a simpler way that if you look at these two soil columns, then this is a dry soil column and when precipitation occurs on a dry soil column, it first satisfies or saturates the soil and then overland flow starts taking place and that is a Hortonian or infiltration excess flow. On the other case, the soil column is saturated and because it is already saturated, so whatever precipitation occurs, it starts flowing in the form of overland flow. So, it is called saturation excess or saturated overland flow or saturation excess overland flow. So, these are the two different processes. Now, we come to subsurface flow and subsurface flow refers to the movement of water beneath the earth's surface within the soil, regolith or rock layers, that is below the soil surface this occurs. Primarily occurs on vegetated surfaces in humid regions where the infiltration capacity of soil exceeds observed rainfall intensity for all except the most extreme rainfalls. That means, when the infiltration capacity of soil is higher than rainfall intensity, then of course, the entire water will be absorbed and then the flow will start taking place. The subsurface flow becomes the primary mechanism for transporting storm water to streams in such areas like there is vegetated surfaces in humid regions. The flow occurs through the unsaturated or saturated zone below the ground surface. So, we have seen a part of infiltrated water either flows as a subsurface or it percolates down and joins the groundwater, and then the groundwater flow takes place. But typically the subsurface flow velocity are very slow, and thus subsurface flow alone cannot contribute a significant amount of storm precipitation directly to stream flow. So, during the storm, it is the infiltration excess over land flow that carries most of the water to the streams. Subsurface flow, however, is a critical component of the hydrological cycle and influences various environmental and geological processes. So, of course, we have seen that the base flow is very, very important, and that contributes to stream flow in a larger way. Now, this is just a idealized cross section of a hillside draining into stream, and this is such that we have on this surface there is a flux of 0.005 centimeter per second, and this side is impermeable but allowing seepage force development from base with time, and initial condition is static, that is prior to rainfall stream surface is equilibrium with the water table and no saturated subsurface flow occurs. So, there is no saturated. So, this is what it is, this is water table, and these are impermeable sites. Initial and boundary conditions are the constant flux until surface saturation, constant head thereafter until the end of flow, and no inflow outflow thereafter. So, what happens here, that this is initially the condition, but if this flux continues, then let us say at t equal to 45 minutes, that is 45 minutes after this flow has started, you will see that seepage pattern develops. As you can see, the seepage pattern is developing. And then what happens, that after certain period of time, because of the distances, flow distances, this part reaches the groundwater first, which is here, and this groundwater starts rising, and that is what the case you can see here at T75. Similarly, at 211 this will continue, and then of course, as you can see here, seepage phase will develop here, that means flow will start taking place, though it is because it says that it is impermeable, but seepage flow takes place. So, obviously, here this will continue till t equals to 277, that the water table continues to rise until inflow ceases at 277, and beyond 277 what happens, you see there is a groundwater decline, that water table declines, and finally it reaches equilibrium. So, this is how the subsurface flow process takes place in a idealized conditions. Now, we come to the types of stream, and based on the runoff characteristics, that streams are categorized either as ephemeral streams, intermittent streams, and perennial streams. The basic difference between these is that the flow carrying period in a given year. So, perennial stream carries water throughout the year, intermittent stream carries flow during the monsoon season or whenever there is a rainfall, and ephemeral streams only carries flow during a storm or immediately after storm. So, ephemeral streams have a highly variable flow pattern and are often dry for extended periods. They flow only in direct response to precipitation. Flow can vary significantly with short time frames, particularly during wet season. So, when rainfall occurs, if the flow is such that it creates a stream on its own, so that is a ephemeral stream. Wherein intermittent streams flow for a part of the year and may stop flowing during dry seasons or droughts. They have seasonal variability of flow. They have relatively more consistent water flow compared to ephemeral streams lasting for a defined part of year. So, here it is only following a precipitation event ephemeral stream carries flow, where in this case they have consistent water flow compared to, because they flow over a season or so, wherein perennial streams flow consistently throughout the year irrespective of the season owing to a sustained water source. they are typically fed by groundwater, springs or other sources that ensure continuous flow. So, the typical perennial streams, most of in our country like Ganges and all, they get most of their water from the glacier melt basically. So, Gangotri, Yamunotri, so Ganga, Yamuna, they get from Gangotri, Yamunotri, because there is a glacier melt throughout, and that is why there is a flow. Streams can also be divided based on the flow of water and the structure of the river network, and based on this they can be called as effluent stream or influent stream or gaining stream or losing stream. An effluent stream receives water from the ground and therefore it expands downstream by becoming deeper and broader. River systems are found mainly in tropical and temperate climates. So, here as you can see that they flow their level of flow is such that the water table, groundwater table contributes significantly to this. So, that is why they are referred to as gaining stream. On the other hand, influent stream, the stream or river that contributes its water to another water body such as lake, larger layer or an ocean, that means their flow pattern is such that they lose water, and that is why they are called losing streams, and they are found mostly in arid areas. So, this we have seen the stream flow processes. Also, we have tried to classify streams based on the flow pattern or based on the flow of water in the structure of the river network. With this, we close this lecture. Thank you very much. I hope to get your feedback, and also please raise your doubts so that we can answer your questions in the forum. Thank you very much.